Welcome back. Now we'll be solving some examples on the kernel of a linear map, so it will help you know what we're actually saying. Look at this question here. Now they say we should find the kernel of t, KR of t, if the linear map t is mapped from R3 to R2. So the vector spaces here are R3 and R2, right? And they are defined by t of x, y, z, which is x plus y and y minus z. So then what is its nullity? Let's start first by analyzing the question given to us. Now, if you look at the question given to us, you see carefully that we can say, or we can define our kernel. Don't forget the kernel, like we said. I said kernel is a vector v, which is an element of capital V, such that your t of v, right, must be equals to 0 of w. Now we're going to, this is a general way of defining your kernel, but let's define our kernel now as related to the question given to us. Now what is V? Don't forget that when I defined this kernel for us in the previous video, we said that our T was mapped from V to W. Do you remember? Now if you look at this question, it's mapping from R3 to R2. So R3 in this context is X, Y, Z. Are you seeing it? Which is an element of capital V. And what's capital V here in this question? R cube. So this is where you model your question such that what? T of V, what's T of V? X, Y, Z again must be equals to what? Your 0 codomain. Now your codomain here is R2. So this is the way to model your question. So this is the kernel of this map, but we are going to solve this. But this is the first step to take. After you have done this, you will now see, you ask yourself, for R2, what is the for R2, what's your 0 vector? It means that you have something like this, x, y, z, which is an element of R cube, right? Such that t of x, y, z will be equals to 0, 0, since it's mapping to R2. Okay, so this is your kernel. Now you ask yourself that what is t of x, y, z? What's this guy? Look at it in the question. So that implies that x plus y, y minus z must be equals to 0, 0. So I believe this is making sense. Okay, so this also implies that x plus y is 0, right? Or y minus z is 0. Now if x plus y is 0 or y minus z is 0, the first thing you want to do is this: to find kernel. This is the way we go about it. You let your z be equals to k. Let z be equals to k. Always do this. Always do this for questions like this, right? So if you let z to be k, what does that mean? That implies that your y is z, right? Which means that your y is k. Now if y is k, what is x? From this question, as you can see here, your x is negative y, which means that your x is negative k. Since we have said y is k, so that implies that x is negative k. You now come back to your kernel equation. You now say kernel of t equals to, now the reason for doing z because of k is because we want to write all the coordinates x, y, and z in terms of k, right? So we can bring k out as a constant. So what are we saying in essence? Our kernel of t now, let's come back to this equation, is what? X, y, z, where our x is minus k, the y is k, and your z is k. Z is k, y is k, x is minus k, right? And this is an element of R cube, such that, what will you now write now? You won't write this since we have solved already. Such that the k that we choose must be what? A constant. Okay, so once you have done this, the next thing is you can factorize the k out. So if you factorize the k out, you just have minus 1, 1, and 1. Okay, just follow it step by step. This is what to do step by step to find your kernel. After you have done this, you can now say that the kernel of your map T is actually equals to the span. Okay, is actually equals to the span of whatever you have here, the set minus 1, 1, 1, and this is your final answer. So the kernel of this map T is minus 1, 1, 1, the span of this guy. Okay, and then they ask us to find the nullity. So your nullity, like we said, nullity is what? The dimension of your kernel, right? So if you look at, to find the dimension of your kernel, the dimension of your kernel is the number of elements, or the number of elements you have in this set. As you can see, it's just one element you have in this set of your span. So your nullity is equals to 1. how do I know the number of elements? You know, this is like a set, right? When I define kernel of a map, I told you that it's a set of vector v which is an element of capital V, and also. So this is our set. The span of this set is just having one element, and the element is this minus 1, 1, 1. This is an element. This entire xyz guy is an element. Okay, so your nullity is 1 and your kernel is span of minus 1, 1, 1. Let's pick another example. Let's see another example. You can pause this video and learn it at your pace. You don't need to have to watch everything brute forcefully. Okay. Or better still, I think I should just, I don't want to pause it. I know I promised that time I was going to give 2 minutes videos, but it's not going to be possible that way because of time. So let me just do everything brute force, and please watch it. Thank you. Okay, watch it till the end. It's important. Now let's look at another example. And look at this example. Okay, given the transformation, given the linear transformation, T, this time around we have a polynomial mapped from polynomial of degree less than or equal to 2, such that your polynomial is also mapped to a similar polynomial P2. Okay, so defined by, now look at this question, defined by T of A plus bx plus cx squared equals to ax plus bx squared. Okay, and then we are asked to determine the kernel of T. We are asked to determine the kernel of T, and we also have to find a basis. Okay, we have to find a basis for the kernel of T. We have to find a basis for the kernel of T, and then also we have to determine its nullity. We have to determine its nullity. Okay, and this question is very, very simple, but you need to pay attention to details. So let's solve together. Solution. Now look at this question. The first thing first is you want to find your kernel, and this time around you have a polynomial, so you have to understand what a zero polynomial looks like to understand how to model your kernel. Now don't forget, the kernel of T equals to the general formula, the general equation for your kernel I said is the set of V, such that, set of V is an element of your vector space V. Don't forget, when we started we said T such that you have your V mapped to W. Hope you've not forgotten. So so we said the kernel is simply this guy, such that T of V is equals to the zero vector of W, your codomain, right? So if I'm going to mimic this same thing in this case, we have P2 to P2, so you have something like this. You have A plus bx plus cx squared. So this guy is representing P2, as you can see here. Okay, must be an element of P2, right, such that T of A plus bx plus cx squared, right, must be equal to the zero polynomial P2, right? Now the next question you want to ask yourself is, what is the zero polynomial P2? What is the zero polynomial P2? So you say A plus bx plus cx squared, right, must be an element of P2 such that T of A plus bx plus cx squared equals to, so the zero polynomial of P2 will simply be 0 plus 0x plus 0x squared. So this is the zero polynomial of P2, of a polynomial of degree that is less than or equals to 2, as you can see here. So what's the next thing to do? You will agree with me that you equate what you have here to ax plus bx squared. So this implies that ax plus bx squared, why am I equating them? As you can see, this question says T of this guy is this, and we have already said T of this guy is 0, right? So which means that 0 plus 0x plus 0x squared is actually equals to this. Okay, so what are the things that will derive from here? As you can see, so you compare both sides. So comparing both sides implies that your A, as you can see, is 0, your B also is 0. However, but C can actually take any value. So that's the catch. C can take any value actually. Why is it that C is taking any value? It's because C is not defined. It's not defined. Don't say C is 0. No, it's not defined. So A is 0, B is 0, as you can compare both sides, but C is not defined. So it's not that it's going to take any value. So C is not defined, so that's why we say C can take any value. So for that reason, your kernel of T, the kernel of your linear map, now will be equals to we have A plus BX plus CX squared. We have said that A is 0, so we have 0 plus 0x plus CX squared. Since we said C can take any value, right, which is an element of P2, so you can say C is an element of what? Of R, is a constant. So this means that you have now if you write this as what do I put it now as if you put it in a bracket, what would you have? You have CX squared, right? And I can actually write this as C into X squared, which is an element of P2, right? Such that C is an element of R. Now our kernel finally will now be equals to the span, the way we did the first example. Span of what? Span of just X squared. So basically this is your kernel. Then your basis, to find the basis for this kernel, alright, to find the basis for this kernel, you have hold on. Anyways, nullity is 1, so take note, your nullity is 1 too. Nullity is 1 because you just have a single element here. You have a single element in that particular one. So take a while to look at what I've done so far. Alright, so for this basis for the kernel, let me give you as an example. Try and figure it out yourself. This is an assignment. Submit to me individually. Let me see what you do. Okay, let's move to another example, the last example, before I give us our exercise. Don't forget, all exercises should be submitted individually. Okay, so let's look at the example 3. Let's look at the third example and the final example for kernel before we move to another subtopic. Now, look at this question. What is kernel of T, KR of T, and nullity of T for the linear map? T is such that M22 is mapped to M22. Exactly. You have a matrix here. Alright, so defined by T of A, which is equals to KA, alright, where K is a non-zero real constant. Is a non-zero real constant. Okay, now look at this question. Now to solve this, you must first understand that you are dealing with a matrix, right? So you would want to first assume a value for A. Okay, so you can let A to be equals to, since it's a 2 by 2 matrix, as you can see here, so you can say A is A11, A12, A21, A22. You know the drill, right? So you want to find the kernel. So what do you define kernel as in this case? See what you are mapping from, M22 to M22. So you can say that your kernel will be the particular matrix A11, A12, A21, A22, right? Which is an element of M22, such that T of A11, A12, A21, okay, A22 equals to what? Zero vector, zero vector for your matrix. Haven't done this. Now this implies, you agree with me that this simply means that your KA, as you can see, since what is this guy, what is this T of A in the question is given as K is, that means K of A11, A12, A21, A22 actually is equals to 0, 0, 0, 0. Now this implies that our A11 is 0, A12 is 0, A21 is 0, and A22 is 0. Now once this is established, you will agree with me that our kernel is actually our zero vector space. Is this 0 guy? Because your kernel will just be actually equals to K into 0, 0, 0, 0, right? And if this is established, it simply means that sorry, it's not R, it's M. It's an element of M22, okay, such that your K of course is a constant. Now if this is established, it means that your kernel is actually the zero vector space. So this is what we mean by zero vector space. At least for a matrix, this is its zero vector space. Okay, so you might now want to write it this way. The kernel of T is actually equals to the span of 0, 0, 0, 0, this particular set. Okay, and this guy is equals to your zero vector space. Is equals to your zero vector space for M22. Okay. And now your nullity of T equals to 0. Why is nullity of T is equals to 0? I think I already said that in the when I was explaining kernel. I told us that the kernel, the zero vector space, when you have a zero vector space, you won't have any basis, right? Because it cannot form a basis. And why is that? It's linearly dependent. So we said that the nullity is 0 since it doesn't have any other basis. So the nullity for this question is 0. Now try this yourself. So you can pause the video so you can be able to you can take a screenshot or write the exercises down. So try these exercises yourself. Alright, and please submit to me once you are done.